Hello friends, good morning. I am Dr. J Prasad, working as an assistant professor in the Department of Electronics and Communication Engineering of KPR Institute of Engineering and Technology. In today's session, we are going to discuss CMOS circuit based designing of static and dynamic latches and register. So here are the content today we are going to discuss. So firstly, we are going to discuss the very basic difference between what is static and dynamic latch, and followed by few difference between latches and register. Then we are getting to designing of CMOS circuit based latches and register using of two different type of transistor technology, which is called to be an pass transistor and transmission gate. So let me explain what are the basic difference between static and dynamic latches. Say for example, if I am taking of static memory, the memory cell is made up of cross-coupled connection of two logic gates, that is bistable latches. Okay. Kindly look at the figure. The gate 1 or gate 2 both are connected in cross-coupled connection. So what do you mean by a cross-coupled connection means the output of gate 1 will be act as an input for gate 2. Gate 2 output will be connected to input of gate 1. So I called gate 1, gate 2 will be connected in cross-coupled connection. So in static memory cell, the memory cell is made up of bistable latch. So actually that memory cell is connected through two metal lines, surrounded by two metal line. The purpose of metal line will be through that metal line only we are going to connect the input for an static memory cell. It may be 0 or 1. So both metal line will be having of complementary inputs. The transistor T1, T2 are the responsible for whatever the input we have connected at metal line. It will be passes to static memory cell through transistor T1. And whereas in a dynamic RAM memory, the memory cell is a consist of transistor followed by capacitor. So dynamic memory also and require of metal line for passing of input. So in what basis we are going to identify the capacitor will be holding of logic 1 and logic 0 as, for example, when transistor T1 become an on connection, the capacitor will be charging the information. So I called it as logic 1. When transistor become an off connection, the capacitor will be started to discharge the energy. So I called it will be storing of logic 0 signal. So T1 it become an on connection or off connection based on the control signal. If control signal equal to 0, the transistor will be an off condition. If T equal to 1, whatever the transistor become an on connection, so whatever the input that you have connected at bit line, it will be transferred to capacitor. So this is the basic difference between static and dynamic memory. And one more drawback of dynamic memory is, since it consists of a MOS transistor, hope you remember, this is one of the second order effect of a MOS transistor is called to be a leakage current. So since the MOS transistor is suffer from a leakage current, the periodic refresh operation must is required for dynamic memory. Next, the difference between latches and register. Like in a latches, it is called to be a level triggering. A register, it is called to be an edge triggering. So what do you mean by level triggering and edge triggering? So that I will explain with a simple block diagram. So kindly look at the block diagram, which is called to be a sequential logic circuit, combination having a feedback connection. So the feedback connection component will be called to be in a memory. It may be in a latches or it may be a register, whatever it may be. So the combination logic circuit output will be generated based on the external input signal and the feedback input. The information stored in a memory is called to be in a state of memory. So the output of a combination logic circuit depends upon the external input signal as well as feedback connection. So kindly look at the block diagram. That memory, it is under control of clock signal. It is under control of clock signal. Then what do you mean by a clock signal is, kindly look at the waveform. It is a periodic square pulse. So there are few characteristics of, few important characteristics of clock signal will be. So how do we calculate one complete cycle of a clock signal is the time duration of logic 0 time interval and logic 1 time interval, which is called to be one complete cycle of a clock signal, correct? So if the information stored in a memory, it will be connected to input of in a combination logic circuit during flat 1, it is called to be an positive latches. If the information stored in a memory, it is connected as in a feedback input during logic 0 time interval, flat 0 time interval, it is called to be a negative latches. So likewise, the information stored in a memory, if it is connected to input of a combination logic circuit during rising edge from 0 to 1 transition, it is called to be an positive edge triggering. If it is happened during falling edge from 0 to 1 time interval, it is called to be an negative edge triggering. So what is the conclusion is, the latches will be changes its state either flat 0 or flat 1. When register will be, flip-flop will be changes its status during 0 to 1 time interval or 1 to 0 time interval. So this is simple example. What is the basic difference between positive latch and negative latch? The example, what type of latch I consider here as D flip-flop. So hope you remember what is the basic principle of D flip-flop. Data flip-flop is the whatever input data you have connected at D input end, it is followed by output. Speaking simply, the output followed by input. This is called to be a D flip-flop basic principle. If you look at the timing waveform, both in positive and negative latch, both will be under control of clock signal. In positive latch, what is the observation is, from the timing diagram, the first waveform it indicates to be in a clock signal what we have connected for positive latch. So the output will be following of input during only logic 1 time interval. Whereas in logic 0 time interval, the output will be become stable. So this is what basic principle of a positive latch. If you are taking off a negative latch, the output will be following of input during logic 0 time interval. During logic 1 time interval, the output become stable. So this is what very basic difference between positive and negative latch. Like positive latch will be, the output will follow during logic 1 time interval, where negative latch will be following the input during logic 0 time interval. So with this short summary about static and dynamic memory and latches and register, next we are going to discuss how we are going to designing of D type of latches using of static CMOS logic. Okay, so kindly look at in both circuit like an pass transistor logic, transmission gate logic, how it will be act as a latches means. Before that, let me explain the basic operation of pass transistor logic and transmission gate logic. So what do you mean by a pass transistor logic means, which is nothing but single NMOS transistor or single PMOS transistor will be act as a pass transistor logic. So you might have a question, how far it is differ from normal NMOS transistor is. So kindly look at the graphical symbol of MOS transistor, which is called to be an enhancement NMOS transistor. Basically in enhancement MOS transistor, what we are doing is, the source terminal is connected to ground connection. Whereas in pass transistor logic, the source will be, instead of connecting to the ground, it will be connected to some input signal. So what pass transistor will be do is, whatever input information that you have connected at source end, it will be passes to drain terminal according to the control signal what we have connected for gate terminal. If transistors become an on condition, the source will be connected to drain. If transistor become an off condition, it acts as an open circuit. So this is simple difference between NMOS pass transistor logic and PMOS transistor logic. If I am taking up NMOS transistor logic, the control signal G, G is called to be a control signal. Hope you remember, NMOS transistor become an on condition when control signal equal to 1. If it is 0, the circuit is become an open circuit. So when gate terminal equal to 1, they form in a closed path. It form in a path from source to drain terminal. So whatever information we have connected at source end, if it is 0, passing to output end. If it is 1, it is passing to output 1. Okay. So what is the summary about NMOS transistor is, for in pass transistor logic, the output will be VGS minus VTH. Okay, so according to this logic, the NMOS logic will be passing of strong 0 signal, and whereas passing of weak 1 signal. If I am of PMOS transistor, the control signal, PMOS transistor become an on connection. So based on the control signal G, if it is 0, it's form a closed switch. When G equal to 1, it form an open circuit. When G equal to 0, whatever information you have connected at source end, it passing to drain end. Okay, so the summary in PMOS transistor, it will be passing of strong 1 signal whereas weak 0 signal. And coming to transmission gate logic, like the main drawback of pass transistor logic is PMOS transistor passing of weak 1 signal, where NMOS transistor passing of weak 1 signal, PMOS transistor passing of weak 0 signal. To overcome that problem only, we go with transmission gate logic. In transmission gate logic, how the transistor will be constructed as, so both PMOS transistor and NMOS transistor are connected in parallel form. Okay. So the transistor, it will be passing of information what we are connected at input end, it will be passes to output end based on the control signal A and A bar. So let me explain you how transmission gate logic will be works. So speaking simply, when both PMOS transistor and NMOS transistor are in open connection, no input information will be connected to output. Remember that when both PMOS transistor and NMOS transistor are become an open circuit, I called output will be high impedance state. When both PMOS transistor and NMOS transistor are connected, the input will be passing to output. This is basic logic. So kindly look at the table column. So first control signal, if I call control signal A will be 1 high, A will be 1, so A bar will be 0. So both PMOS transistor and NMOS transistor will be on connection. So if I connect input will be 1 passing to output. If I connect input equal to 0, output will be followed by input. In case if I exchange the control signal, for example, if a control signal instead of high, I will be taking A control signal will be low. So what happened is both PMOS transistor and NMOS transistor both will be open connection. So input should not be reaches to output end. So I called it as an high impedance state. So with this basic discussion of transmission gate logic and pass transistor logic, let me explain you how these two logic will be help us to designing of static CMOS logic. Okay. So for kindly look at the pass transistor logic circuit diagram. It consists of two transistor T1 and T2. So let me, this is equivalent circuit for designing of D latch. So let me remember the basic concept began D latch will be the output will be following of input signal. So this transistor, the D latch will be, it will be working on two mode, loading mode or holding mode. So when it will be on, when it will be under working of loading mode and holding, loading mode and holding mode is based on the transistor T1 and T2. The T1 under the control of control signal C and T2 will be under control of C bar. So if I am taking C equal to 1, so what happen is T1 become an on connection, T2 become an off connection. So what happened is feedback path loop will be disconnected. Only the data D, since T1 will be on connection, the data D will be loading on the latches. If I exchange the control signal from C equal to 1 to 0, what happened is T1 will be disconnected, T1 become an on connection. So what operation will go performed as holding operation. So this is simple equivalent circuit with respect to control signal C equal to 1, C equal to 0. If C equal to 0, as I said, transistor T1 will be on connection, T2 will be open connection. So loading operation will be performed. If C equal to 0, T1 will be disconnected, T2 will be on connection. So it will be performing of hold operation. Now coming to transmission gate logic, the circuit construction will be remain same. The two inverter connected back to back connection form a static latch. So instead of pass transistor logic, T1, T2 will be replaced to transmission gate logic. The operation principle remains same. If C equal to 1, what happened is T1 will be active, T2 will be deactive. So loading operation will be performed. If C equal to 0, T1 will be deactive, T2 will be active. So what happened is hold operation will be performed. So next we are going to discuss designing of master and slave flip-flop using static CMOS latch. The type of latch will be, again here I am calling to D flip-flop. So since it consists of both master and slave, I put two static latches for two static latch. The combination of G1 G2 will be act as a master, and G3 and G4 static latch will be act as a slave. So the summary, at the instant of time, either master will be do loading operation or holding operation. Slave will be do either holding operation or loading operation. So loading operation on both the master and slave, holding of master and slave will be at instant of time. It is not possible. If it is performing of loading operation, then slave will be loading operation. Sorry, holding operation. If slave will be do of an loading operation, so it will be do of holding operation. This is in short summary. So let me take in a circuit diagram. Actually, the combination of G1, G2, it acts as a master. For loading operation performed through transistor M1, for holding operation performed through M2. Likewise, for loading operation of slave will be with respect to with respect to transistor M3, and holding operation based on M4. So if I am taking control signals I equal to 0, what happened is transistor M1 will be active and M2 will be deactivated. So what operation performed on master is loading operation. So what will be the output at gate 1 is, if I am taking D equal to 0, if since mass transistor M1 will be, pass transistor M1 is on connection, it is connected through the transistor M1, 0 it is connected to input of gate G1, it will be to inverting 1. So the output at the gate N G1 will be D bar. Okay. So next, if I change the control signal phi equal to 1, what happened is transistor M1 will be disconnected, M2 become an active connection, M3 become an on connection, M4 will be disconnected. So what operation will be performed on master is, since M2 is activated, it will be holding operation. Whereas in slave operation, since transistor M4 will be disconnected, the loading operation will be performed on slave operation. Okay, so for example, as I said, the D flip-flop, in D flip-flop, the output is following of input. For example, if I am taking D equal to 1, when during phi equal to 0, the output at G1 will be D bar, it is D bar, so it will be, I connect if D equal to 1, output will be 0. Again, when slave is activated, loading operations performed, through transistor M3 it is connected to G3, the D bar 1 it is 0, 0 again it is converted to 1. So the conclusion, what output will be following of input. And next is multiplexer based static CMOS latch. So actually in the respective slide, I put in two different block diagram. The first one for negative latch, second one for positive latch. So what is the basic difference between negative and positive latches? So both will be comprises of a 2x1 multiplexer. In negative latch, the selection line will be, control signal clock equal to 0. If clock equal to 0, the loading operation will be performed, D equal to 0. Okay. When clock equal to 1, the feedback loop, holding operation will be performed. Whereas in positive latch, when control signal clock equal to 1, loading operation will be performed. When clock equal to 0, the feedback loop, holding operation will be performed. So this is what very basic difference between negative latch and positive latch. The conclusion for negative latch, selection line will be, if it is 0, D will be connected. Whereas in a positive latch, if clock is equal to 1, D will be connected to output. So this is simple design for designing of positive latch using 2x1 multiplexer. So in circuit diagram, I have designed 2x1 multiplexer using a transmission gate logic. So let me explain how 2x1 multiplexer will be designed using a transmission gate logic. So like this is first graphical behavioral representation of a multiplexer. of 2 cross 1 size. So what happened is when selection line S equal to 0, M0 will be selected. If S equal to 1, then output Y will be following of M1. So this is transmission gate logic for designing of 2 cross 1 multiplexer. It comprises of transistor T1, T2. It is under control of selection line S. So what happen if S equal to 0, T1 will be connected, T2 will be disconnected. So output will be following of M0 input, and whereas if S equal to 1, the transistor T1 will be disconnected, T2 will be on connection. So output will be following of M1. So this is what designing of 2 cross 1 multiplexer using transmission gate logic. The same design only I have applied for designing of static CMOS latch for positive latch. So kindly look at the second block diagram. This is basic behavioral representation of positive latch. When clock signal equal to 1, it will be performing of loading operation. When clock equal to 0, it will be do an holding operation. So let me apply the same logic for a transmission gate logic. If clock equal to 1, what happened is T1 transistor will be disconnected, T2 will be on connection. So what happened is loading of the data operation will be performed over the latches. If I change the control signal C clock equal to 1, the transistor T2 will be deactivated, T1 will be activated. So feedback operation, that is holding operation, will be performed. Next, the same transmission gate logic applying for multiplexer based D latch for designing a master slave edge trigger register. Since it consists of both flip flop, I put two multiplexer, both having of 2 cross 1 size. So master will be followed by negative latch, slave will be followed by positive latch. So kindly look at the waveform. So what is the observation is, since master will be negative latch, during logic 0 time interval, QM will be of D. Since slave will be following of positive latch, during logic 1 time interval of clock signal, Q will be following of QM. So this is transmission gate equivalent model for designing of master slave using of 2 cross 1 using of transmission gate logic. So figure 1, it's a simple block diagram, and block diagram 2 will be detailed block diagram using of transmission gate logic. So actually consists of 2 cross 1 multiplexer. So that is why I put a 2 cross 1 multiplexer. So how the circuit will be works as I said, the master will be following of negative latch, slave will be following of positive latch. So what happened is, when clock equal to 0, out of 4 transistor, the T1 is activated and T1 and T4 will be activated. So what happened is, in master end, loading operation will be performed, whereas in slave end, holding operation will be performed. If I interchange the control signal, clock signal 0 to clock 1, so what happened is, T2 is on connection, T1 will be disconnected connection, and T3 will be deactive and T3 will be active connection and T4 will be deactivated. So what operation will be performed over master master end is, it will be do an holding operation, whereas in a slave will be loading operation. So next we are getting to dynamic register design using of CMOS transistor. So these are the 3 classification of an dynamic register. So let me discuss one by one. So before that, I would like to remember you the basic difference. So far we have discussed only static. So here we are going to concentrate on dynamic register. So let me recall the very basic difference between static and dynamic latches. In dynamic latch, the memory device is called to be a capacitor, whereas in a static will be cross-coupled bistable latches. Okay. So this is simple designing of master slave register using of transmission gate logic. It comprises of transistor T1 and T2. So the memory device C1 for master device loading, for master device, the memory device C2 will be for slave operation. So what happened is, so this is again same principle. Since it is in a D type of register, the output Q will be following of input D. So what happened is, when clock signal equal to 0, transistor T1 become an active connection, T2 become an deactive connection. So master will be activate and slave will be deactivate. So loading operation will be performed over master end. And if I interchange the control signal from 0 to 1, T2 become an on connection, T1 will be off connection. So slave will be active. When slave will be active, when T2 transistor is active, so whatever the energy, whatever the information stored at C1 will be, test cube C will be transferred to the capacitor C2. So these are the two issues in designing of dynamic register using transmission gate logic, which is called to be a 0-0 overlapping and 1-1 overlapping. So kindly look at the timing diagram. So we can observe that we supposed to be connecting of clock signal and bar will be, both will be out of phase. Both will be out of phase. So since both clock and clock bar will be out of phase signal, on certain time duration, both clock control signal and clock bar control signal will be 0. So both should be 0. So what happened is, when both clock and clock bar, kindly look at the circuit diagram. So since clock and clock bar both will be 0, so what happened is, PMOS end of T1 transistor and PMOS end of T2 transistor will be, both will be active. Both NMOS transistor of T1, T2 will be deactivated. So what is the observation is, since PMOS transistor of T1, T2 is connected, the direct path will be exist from D to Q. So this is major drawback in dynamic register. If I am taking off 1-1 overlap, what happened is, NMOS transistor of T1, T2, NMOS end of T1, T2 transistor both will be on connection. So direct path will be exist from D to Q. So this is the major issue in a dynamic register using transmission gate logic. To overcome that problem only, we go for C-square MOS transistor register. So what is the basic principle behind MOS transistor register is working based on tri-state buffer logic. So before I may explain this circuit diagram, so first let me explain you the basic principle of tri-state buffer logic. So why it is called to be a tri-state buffer logic is, the output will be producing of 3 levels, 0, 1 and high impedance state. So for example, let me take an inverter circuit like PMOS 1, NMOS 1, the combination of PMOS, NMOS 1 under control signal of input A. The combination of PMOS, NMOS 1 will be act as an inverter circuit, and like PMOS 2, NMOS 2, it's under control of enable bar and enable control signal. Okay, so with respect to enable control signal only, the inverter will be, it will be generating of either 0 operation, it will be producing of 0 output or 1 output or high impedance state. So just we have remember in CMOS logic, in CMOS inverter logic, when PMOS is connected, output will be VDD, I mean pull up output. When NMOS will be on connection, the output will be goes to be in a ground level. So what I am trying to say is, you might have a question, when PMOS is connected, output will be 1. When NMOS is connected, output will be 0. So then what do you mean by high impedance status? Speaking simply, as per the logic began in a CMOS inverter circuit, at an instant of time, either PMOS is connected or NMOS is connected. So what do you mean by high impedance status? At an instant of time, if both transistors become an off connection, the condition is called to be a high impedance. This is what indicated in second graphical representation. So this is condition when it is happen, when it high impedance state will be occurs when enable line equal to 0, PMOS transistor, PMOS 2 and NMOS 2 both will be off connection. So the input should not be connected to output end. It should not be to inverting operation. Since the output should not be stay at the VDD level or it should not be connected to VSS level. So this is called to be an high impedance state. So what happened when enable line equal to 1? Both PMOS 2 transistor, NMOS 2 transistor become an on connection. So it form an inverter circuit. So whatever input you have connected at input end A, it will be inverting at output end Y. So if A equal to 1, output will be 0. If A equal to 0, output will be 1. So this is if both transistor is PMOS to NMOS to is off connection, it is called to be an high impedance state. So with the short discussion about CMOS tri-state buffer, so let me explain you how that 0, 0 and 1, 1 overlapping of transmission gate logic or designing of dynamic register will be overcome by using of C-square MOS transistor register. Okay. So since it is in a master slave, I put a two tri-state buffer for master stage and slave stage. The combination of M2, M1 will be act as an inverter in master stage, whereas M3, M4 based on the clock signal, it will be do either it will be go for I impedance or 0 state or 1 state. In slave stage, the transistor combination M5, M6 will be act as an inverter circuit, whereas M7, M8 will be under the control of clock and clock bar control signal. Okay. So let me explain the circuit operation. When clock equal to 0, what happened is out of 8 transistor, the transistor M4, M3 both become an on connection, whereas M8, M7 will be disconnected. Speaking simply, master will be active and slave will be deactive. So what happened is, since D input is connected to M2, M1, both will be doing of inverting operation. Whatever input you have connected at D input end, it will be do inverting and it will be stored across CL1. If I change the control signal clock equal to 1, so what happened is M4, M3 will be off connection, M7, M8 will be active connection. Speaking simply, master will be deactivated, slave will be activated. So what happened is M6, M5 forming an inverter, the D bar output stored across the CL1 will be connected to CL2. It is Q equal to D. So this is circuit schematic for 0, 0 overlapping. So as I said, 0, 0 overlapping means both clock and clock bar both will be 0. So when 0, 0 overlapping, what happened is the transistor when 0, 0 overlapping, what happened is when PMOS end of both master and slave will be active and NMOS transistor will be disconnected. So the direct path should not be exist from D to Q. When 1, 1 overlapping, what happened is PMOS end of master stage and slave stage will be open connection. So there is no direct path exist from D to Q. Thank you.